Okay, so welcome back. We're going to move back into our study guide. So we're looking at figure 1. So for the relationships 1 through 4, so the 4 different types of angles that we've been introduced to in section 1 and section 2 of chapter 3. For those angle relationships, alternate exterior, alternate interior, corresponding consecutive interior angles, to hold true or be valid, what must be true for those angle relationships that are special? And when we say that, we're saying that same-side interior angles adding to 180 degrees in the other 3, alternate exterior, alternate interior, corresponding angles, those degree measures of those angle pairs being equal. What must be true about the 2 coplanar lines that intersect the transversal? Right, you got it. So the coplanar lines must be parallel. And we know that these 2 coplanar lines are parallel because we see arrows that show that these lines will never intersect, that the distance between them will always be the same. And that is kind of sad. Anyway. So does the above figure allow corresponding alternate alveolar angle to be valid or hold true to the relationships? And we could say yes. Angles of pairs, degree of angle of pairs, corresponding alternate interior and alternate exterior angles will be equal, or otherwise known as congruent. Put the congruent symbol. And then we would say yes, same side interior angles will add to 180 degrees. Okay. So we have that. Okay, so now we're moving on. A little bit different. So for figure 2 and figure 3, we're looking at these. So we have a transversal, and we have 2 coplanar lines that are parallel. And they're supposed to be parallel. Then we have this figure in which our coplanar lines are not parallel. Okay, so for figure 2, and we're going to get into identifying a transversal when we don't have parallel lines. With parallel lines, coplanar lines that are parallel, it's easy to identify the transversal because it's the only line that intersects the other 2 lines twice. But what if you have 2 coplanar lines that aren't parallel? It's a little bit more difficult. It's a little bit trickier. We'll get into knowing that. But for the meanwhile, for the figure 2 and figure 3, for the special angle relationships of congruence and same side interior adding to 180 to hold for the above 2 figures, do they hold? Okay, so we would say that for number 2, would they hold? They would. Why? So 2, the congruence, okay, well, we should just say the special angle properties. And when we say that, we're talking about same side interior angles adding 180, the others being congruent. So special angle properties for figure number 2, but not number 3. And when we say special angle properties, we're saying that like the special relationships in which the angles will be equal to each other with the angle pairs. Okay, so we don't have coplanar lines that are parallel here. So although 2 is corresponding to 6, and 3 is corresponding to 7, 1 is corresponding to 5, 4 is corresponding to 8, 1 is alternate exterior to 7, 2 is alternate exterior to 8, 5 and 3, and 4 and 6 are all alternate exterior, 3 and 6, same side interior add to 180, 4 and 5, same side interior add to 180. Although we can identify those angle pairs, those special congruence, those special properties of congruence cannot hold for number 3 because our coplanar lines, well, we don't have parallel lines here. So although 2 and 6 are corresponding, their angle relationship, their degree measures are going to be different because we don't have coplanar lines. But here, 2 and 6 will be equal for sure because we have parallel lines that are coplanar. So we know because we have parallel lines 2 and 6, 3 and 7 are corresponding, the angle degree measures are going to be equal. But 2 and 6, 3 and 7, they're not. We don't have parallel lines. Same thing goes with alternate exterior. 1 and 7 is going to be equal degree measure. 8 and 2 will be equal. But what about here? Is 2 and 8 going to be equal? And is 1 and 7 alternate exterior angle is going to be equal? No, because we don't have coplanar lines. But what about 4 and 6, 5 and 3, alternate interior? 4 and 6, 3 and 5. Will they be congruent in number 3? No, they won't, because you don't have parallel lines. Will 3 and 6 add to 180 in figure 3? No, we don't have parallel lines. Will 4 and 5? No, we don't have parallel lines. But what about here? 3 and 6, will they hold? Yes, because we have parallel lines. 4 and 5, will they add to 180 at same side interior angles? Yes, they will, because we have parallel lines. Okay, so we'd say figure 2, yes, because parallel lines. That's just the nature of what happens when you have parallel lines like that. Number 3, sorry, it's getting late over here. Number 3 would be no, because because we don't have parallel lines. Okay, so moving on. Perpendicular lines form what type of angles? They form 90-degree angles. So if we say that DK is perpendicular to line segment DK is perpendicular to line segment AT, this upside down T is a symbol for what is perpendicular. I'm not going to say perpendicularity. Okay, so DK is going to be perpendicular to AT, so that means that the 90-degree angles are formed. And to show 90-degree angles within the spaces of, we draw boxes to show the 90-degree angles. If LD is perpendicular to KM, so LD is perpendicular to KM, we have 90-degree angles that are formed here. Okay, so we know. Now moving on, something that we've kind of put off on the side until now. So we have 3 lines that are intersecting. How do we identify the transversal when we have 2 lines that are not parallel? I mean, obviously we don't have 2 lines that are parallel because every line is intersecting another line more than once. Okay, so we know that there's, I guess an easier way to say that is that we know we don't have parallel lines here because we can tell that the distance between any 2 lines is not going to be same. Okay. So what is the transversal of angle 1 and angle 3? Well, an easy way to say it, when we don't have parallel lines, we know that the transversal is going to be the line that intersects the 2 other lines, is the only line that's going to intersect the other 2 lines twice. The other 2 lines will only intersect once with the transversal. In this case, we don't have parallel lines. So how do we identify the transversal? It will be the transversal will be different to every angle pair that is in question. Okay, so for example, angle 1 and 3. The transversal will be the line that shares the line that is shared by angle 1 and 3. So angle 1 I have right here, and angle 3. What line does angle 1 and angle 3 share? Well, they're going to share line M, because angle 1 is formed by lines M and L, and angle 3 is formed by lines N. Angle 3 is formed by lines N and M. So we know that this line is going to be that. Is shared by both of them. Okay. So like I said, angle 1 is formed by lines L and M. Angle 3 is formed by lines N and L. What is a line that is formed by both of them, that is shared by both of them. Well, it's line M. So we could say that the transversal of angle 1 and angle 2 will be line M. Okay, so what is the relationship now? Okay, so if M is a transversal, we're talking about 1 and 3. So are we on the same side of the transversal? Yes. Do we skip an angle? Yes. So what are these types of angles? They're corresponding angles. Will their angle measures be equal? No, because why? We don't have parallel lines. But are they still corresponding angles? Yes, but do they have this special property of congruence when we have parallel lines? No, we don't. We don't have parallel lines. Okay, so what about angle 10 and angle 3? So I have 10 and 3. What line do they share? Okay, they share line M. So what is going to be the transversal if you don't have parallel lines? Okay, so it's going to be, you're going to be given an angle pair. So 10 and 3, they're shared by line N. Yeah. Okay, so the transversal is going to be N. So what we realize from this second example is that for every angle pair will have a different transversal. But for parallel lines, we always have one transversal because our angles always share the same line. Okay. So N, we have 10 and 3. So 10 and 3, what are they? Well, this gets a little bit more tricky. 10 and 3. What kind of angle relationship are? Okay. Well, if it's 10 and 3, so if we have line N, that's our transversal. So by process of elimination, our two other lines are going to be called our what? Our two other coplanar lines. So we have M and L as our coplanar lines. So we have the inside. I'm going to kind of shade in black. So that will be the interior. And then we have the exterior, which is shaded in red. That's called the exterior. Okay, so 10 and 3, are they on the interior or on the exterior? Sorry, I need to make sure I do this right. Go big or go home. Okay. So we have 10 and 3. 10 and 3. Are they on the interior? Yes, they are. They're on the inside of our two coplanar lines. We identified our transversal because it is a line that is shared by both of those angles, 10 and 3. That helps form those angles. So by process of elimination, the two other lines would be coplanar, so I shaded them blue. So on the inside of them are going to be interior. I have interior inside here. This is interior. That's going to be, here, let me zoom in. Just getting to learn how to work this. Okay. So 10 and 3, so that's going to be interior. And so their interior angles, are they on the same side of the transversal? Yes, so what kind of angles are they going to be? Same side interior angle. That's right. Hooray, confetti. Okay. So then we have 12 and 1. And we could do 12 and 1, so our transversal is going to be what? It's going to be L. So 12 and 1. So if you were to remake this, okay, so 10 and 3, 10 and 1, so this is 1, this is L, so if L is our transversal, the other two are going to be on the inside, but they alternate across, so what kind of angles are they going to be? Alternate interior. Okay. So we're going to move on. Okay, so now we're going to be we're going to be setting up problems. So find the value of x and solve for angle ABC. Okay, so we know that these are two coplanar lines. We have parallel lines, so our special angle relationships hold. These two angles are going to be what kind of angles? Okay, so they're on the same side of the transversal. Call it T. And so they're on the same side of the transversal. They skip an angle. So we're going to say that these two angles are going to be corresponding. So we can say that what type of angle relationship do they have? The angles are going to be equal. So this angle right here is going to be equal to this angle. We know that this angle is going to be 2x minus 45 equals 2x plus 30. And we can say that they're equal because they're corresponding angles. We have parallel lines. Subtract x by both sides. We're left with x minus 45 equals a 30. Add 45 to both sides. We're left with x is equal to 75. Okay. So what special angle relationship allows you to solve for x and ABC and ADC? Would say that the corresponding angle postulate or theorem allows you to solve for this. Okay. We found that x is 75. We know that they're going to be congruent. So angle ABC is going to be equal to 2x minus 45. We just plug in what we found for x back in. 2 times 75 minus 45. Okay, we need to zoom in maybe. I found that x was 75. Okay, so we plug this in. This is going to be 75 times 2, 150, minus 45. And that's going to equal to 105 degrees. Now if you plug it in here, you'll find that it will also equal 105 degrees. 75 plus 30 gives us 105. So these two, that's how you can check that they're going to be equal. You really only need to solve for one. We know that they're going to be congruent. But just for the sake of checking your work, you might want to just plug them into both and make sure that they both equal the same number when you plug back x back into the angle to solve for the angles. Okay, so this will, I think I'll call it a night. I'll post more videos tomorrow on within the study guide to better prep you for taking this test again. If you choose to do better on your second attempt or your first time. Anyways, good night. I'll see you tomorrow. Bye.